All right, today we are talking about section 7.8, solving word problems. This is a section that is not in the textbook. It is an extra section. Our goal today is to solve word problems using trigonometry. Now, I will tell you before we start that there are 4 examples. Once you've gone through the first example, if you feel comfortable, do not feel that you need to sit and watch all 4 examples of word problems. So I'm just going to go through more and more examples. When doing these problems, the biggest thing to remember is with angle of elevation and angle of depression, you are talking about going from the horizon. So in our first example, we are standing on top of a lighthouse 45 yards tall. Jacob notices an ocean line cruiser along the rocky shore. If the angle of depression is 5 degrees, so we start with drawing our horizon, and we know that we are going down 5 degrees. And so here is Jacob up on top of this lighthouse, and he is looking down at an angle of 5 degrees. And thus we create a right triangle. We know that he is 45 yards tall. So if we think about him over here, he's up 45 yards, which corresponds to be 45 yards over here. Now the question is, we're talking about the ship being away from the shore. In this case, we are looking at the horizontal here. Now, from our angle of 5 degrees, there's where theta is. So we are going to label it the 45 is the opposite, and that the unknown distance, x, is the adjacent. When I look at opposite and adjacent, I am seeing TOA, which means I'm going to use tangent to solve. So I will say the tangent of 5 degrees is equal to the opposite 45 over the adjacent x. And just as before, I'll put tangent 5 over 1. I'm going to cross multiply and solve for x. And when doing this, I find that the ship is approximately 514.352 yards offshore or away. Now, in most problems, this would be our final answer. But when we look back at our problem, it says, is the ship far enough from shore to avoid hitting a reef that is 500 yards offshore? Is 514.352 greater than 500? Yes. So our ship is safe from the reef. Our next example, a chairlift on a ski slope has an angle of elevation of 28 degrees. Again, we start with the horizon, and we are looking up because it's angle of elevation, and we know that angle is 28 degrees. And thus we create a right triangle. We know the length along the lift, so that means we have the diagonal piece, the hypotenuse, is 4,640 feet. To the nearest foot, what is the height? So we'll call this piece h of the chairlift. So we just need to solve for h to the nearest foot. So again, we have our theta. H is the opposite, and our 4640 is our hypotenuse. Opposite and hypotenuse, I am using sine because I have so. So the sine of 28 degrees is equal to the opposite, h over the hypotenuse, 4,640. And again, I'll put sine over 1. I'm going to cross multiply. So I get that h equals 4,640 sine 28. which is approximately 2,178.348. Our problem says to the nearest foot. So that means we will say it is about 2,178 feet tall. Our next example. Again, we are going to start with determining are we looking down or up from the horizon. This one says the angle of depression from the top of a 320-foot office building to the top of a 200-foot tall building bank is 55. So this one's slightly different in that we have an office building that's 320 feet, and we have another building here that is 200 feet. And we are looking at this triangle here. Now, what's different on this one is if I look at my horizon, this angle here is 55 degrees. That is not the angle inside my triangle that I've created now. So I need to do 90 minus 55. And I find that the angle right here is 35 degrees. I do not know how wide apart the buildings are. That's what I'm trying to solve for. I do, however, know how much taller the building on the left is. So I'm going to take 320 minus 200 and find that it's 120 feet taller. So this side of my triangle is 120. Now, to solve, I have from theta, here's my opposite, here's my adjacent. Again, I am using TOA. So I'm going to say the tangent of 35 degrees is equal to my opposite, x, over my adjacent, 120. And then I'm going to cross multiply. And I get x equals 120 tangent 35, which is approximately 84.025. So, and again, our problem says to the nearest foot, so we will say about 84 feet apart. All right, and our last example. This one's a bit of a tricky one. We start with, you are a block away from the IDS Center. It's actually a building here in the state of Minnesota. It is the tallest building in the state of Minnesota. It's 792 feet tall. So we're going to draw this tower, and it is 792 feet. Here, the angle of elevation to the top of the skyscraper is 42 degrees. So you are standing somewhere out here such that your triangle has an angle of elevation of 42 degrees. Your friend Jan is standing closer, and her angle is 71 degrees. And we are asking how far away from you are from Janet. So what we will do is we will identify Janet as being y distance away, and we will identify your distance from the building as x. And then in order to find how far you are from Janet, we will take x minus y. So we're going to have to do two separate set of calculations and subtract the differences in answers. So we are going to start with we're going to start with Janet. So for Janet, again, for both people, this distance, or this measurement, I shall say, is the opposite. And then we have the adjacent. So for Janet, we have the tangent 71 is equal to 792 over y. Again, we will cross multiply. And we find that Janet is approximately 272.707 feet away. Now we need to figure out how far you are away. So we're going to do the same thing with 42 degrees this time. So we have the tangent of 42 is equal to 792 over x. Again, we're going to cross multiply and solve for x. And we find that you are approximately 879.605 feet away. This problem asks, how far are you from Janet? So we're going to take how far you are from the building, 879.605, subtract how far Janet is, and we find that you are about 606.898 feet apart.